Hello everyone, my name is Fuge Zou, data scientist from RapidCanvas. Today I'm very excited to give you a presentation on the AI solutions in banking industry. We provide, as RapidCanvas, we provide versatile end-to-end AI solutions for bank using the modern AI technology. This can be viewed as a general use cases that a banking industry need in a daily basis. So first, we have 4 sections. First, we're going to introduce the banking industry background and the status of AI in banking. We're gonna introduce loan approval, corporate credit, and transaction insights, which are 3 simple demos that's showing our capability of our platform can do with the data app, right? So first, we start with the global trend. As you can see, from last year into the 2030, the business value of the world market for AI in banking is growing rapidly, especially all the regions, including all the regions all over the world. They have exponential growth, right? And the future of AI in banks. This is a chart from McKinsey Consulting, and basically highlight what is the AI of the bank into the future, right? You have advanced analytics helps banking to be more efficient than ever before. So the use cases including covering the area of customer acquisition, credit and decision making, monitoring and collections, retention and cross-selling, upselling, and servicing and engagement, right? And this is a chart from Deloitte where we have identified the AI application of AI in the area in the banking organization. So you have your front office in operations, where you have a branch, customer analytics, customer marketing, and merger and acquisition, and you have the core banking industries, where you are using that for retail and commercial banking, right? This is your banking's key business. And you also use that for back office, and for risk and IT. And for in order to covering all these different areas in the organization, you will have all different use cases from AI, right? You have start with marketing, you have customer targeting, customer segmentation, right? Customer retention, and you have product and services which cover the investment, lending, financial advice, right? You also have sales and relationship, just knowing your customer, right? And then you have mid office and back office doing all these like research, fraud, all kinds of use cases, which we provide. And the greatest impact of AI in the value chain is you have the largest in your customer service, right? You can say traditional AI is using all these in sales and marketing, but the AI with a large language model, which is ChatGPT-like chatbot, will help your customer service, and it also help you do all the automation, right? In the back office and operations. The traditional AI will also help you do fraud detection, risk management, right? The end goal is to using the AI to improve your key metrics, such as your access and make your business access to more customer and more scalable. Using the AI and combined with the cloud infrastructure, and you will have the higher efficiency and higher customer value, lifetime value. So this is an example where we have utilized the modern AI, especially with data engineering, big data. We try to do the credit scoring model by using AI instead of the rule-based, right? Traditionally, it's rule-based, right? We're using model-based, AI-based. We are gathering, we can integrate all the customer data, including the basic customer info, their credit history, behavior data, transaction history, and other third-party data. So we will have the final credit score a better quality than ever before, right? So the RapidCanvas demo, in this demo, we're going to show you 3 quick demos, just illustrate the data app of our solutions. So first, we're going to do the traditional loan approval, where we have we prediction loan default rate of a financial lending company. We frame this as a binary classification problem where, however, it can also be framed as a multi-class classification. For example, you can say if this person, if this borrower is a lower class credit rating or higher class credit rating, right? or it could be like a credit score, right? Regression probably is the credit score, or you can also use regression to decide how much is the approval amount to give to this loan borrower, right? So we are using the public data from a global financial institution, a peer-to-peer digital lending company, using the public data. And where the business impact of this loan approval is that you can accurately capture the approved candidate of the loan to reduce the risk of bad debt for the lending company and for the bank, and maximize the risk-adjusted profit for investors, and lower the risk, right? And the second demo, we are trying to focus on the corporate, like a commercial corporate credit rating. We will predict whether the corporate bond is an investment grade or speculative grade. We frame this as a binary classification problem again. It can also be framed as multi-class classification, like you can say this corporate bond rating is AAA or BBB or CCC, depending on how much data you have, right? And we are using historical financial statement from the public traded company in the United States from the web scraping. Then the business impact is whether the bank is deal with the enterprise, right? Small and medium-sized, large banks, large corporations. We've been able to assess the corporate bond rating, can help the bank to better serve the corporate customer, to get a good rate and minimize the risk and maximize the profit for the investors. The last, not but least, we are going to show you a third demo, which is transaction insights. This will be more applicable to more of a like a cold start, right? In the developing countries, or you don't have credit score for the customer or for the loan applicants or any customers. So we're getting financial and credit insights from historical transaction of the consumer using anonymized public open bank data sets, usually for the past 90 days of open bank transaction records. So we have anonymized public open bank dataset. We try to get insights using advanced analytics from the banking transaction data. One can extract the key information and the insights regarding to the customer behavior, credit, and insights for better decision making, such as approving a loan, right, without a credit score. So enough for this background. So we jump into our first demo, which is loan approval. First, look at the data, right? The data is basically a loan application and result. The data of all the loan records from 2014 and 2015. So you can say you have the loan amount. The term is basically a 3-year term, 36 months versus 5-year term loans, which is 60 months, right? People are using this is an interest rate, and this is a grading, the grade of the loan, a grade of the applicants based on the lending company's criteria, right? And you can say you have home ownership, annual income of the loan applicants, and you also have these other status of the loan and financial information of the loan applicants. Our target is to try to predict whether this loan is fully paid or late or default, right? It's either a good loan or bad loan. We are using this data to predict. So you also have state income, debt to income ratio, how many open accounts that loan applicant has, and how much is the revolving balance, and the utility of the balance, which is just utility of your credit line, and also employee history in years, right? So this is open from open public data domain, but it is real data for the peer-to-peer lending company, right? You have about 70,000 total samples of the loan records, and 22 columns. We are trying to predict. Total default loan is about 10% of the entire population, and the year range is from 2014 to 2015. Duration of the loan is either 3-year or 5-year loan. This is a relatively short-term loan compared to the housing mortgage, right? But you can also see the data summary is basically give you the data quality, right? You have how much null value you have, and how much unique values, which is cardinality of the data, and you have the first row and last row. So data definition, as I mentioned, so you have basic info about this loan applicant, whether what is his employee length, how long will he or she work, the home ownership of this person, and annual income of this person, and zip code, address, and public record. And you also have financial info for this person, right? How many open accounts, how many debt to income ratio, what is the revolving credit utility that this person has. Also, you have the information about this loan itself, right? You have what is the grade of the loan, what is the interest rate, and we are trying to predict the results, whether this loan is good loan or default loan. So we are checking some categorical features. You have the term loan. So say most of these are just 36 3 years versus 20% are 5 years. You have a different grade, and you have a different home ownership, verification status, and purpose. And you also have the loan versus time, right? You can say fully paid loan is in dark blue, and default loan is in light blue. You can see how these loans are distributed in through months. And you can have these numerical features, say which one is more of a driver for default. We can say definitely the loan amount, the lower loan amount it has a lower probability of being default, versus the higher loan amount is a higher probability of being default, right? Interest rate is the same story. The higher interest rate is definitely the more leaning towards default. So these are the observations we can have for the future machine modeling. So let's jump into the machine learning model. So we have the feature engineering, try to create critical features that can drive the target variable, which is a loan default or not, right? We are fill the missing values with average, and we are doing one-hot encoding on these categorical features. So we are generating either 1 or 0 for the one-hot encoding. And we also do feature selection where we remove the highly correlable features, because you don't want the model to overfit the data, right? You want to remove these like high collinear problems. And you also remove these features with no information gain, which means they are not driving the results. So they the features with no information gain got removed. So finally, we have our proprietary AutoML, auto machine learning library. We're gonna give you this. We are gonna try all kinds of model and give you the best model results. So the GBM2 is the best model with the summary performance of the model with cross-validation score on the right. So we have done this automated hyperparameter tuning, cross-validation, and all kinds of testing, right? We give you the best model from our platform. And you can see the accuracy is 96% with precision recall also reaching 80%. So this is very good results, right? And this is the most important, where we not only we have a good accuracy, but we also predict why, right? This is a key driver for being try to predict the probability of loan default, right? Yeah, you can see the top drivers are interest rate, where you can, this is a shapely plot, right? This is where you explain whether it is a positive driver or negative driver for being default. So you can see the red to your right is where you have a positive driver, and you can see interest rate, definitely you increase the interest rate, you increase the probability of loan default. That is also the same same with our observation just for the data analysis, right? We see that chart, and you can see higher debt to income definitely leads to more loan default, and a higher loan amount also leads to loan default, and revolving utility is higher, that will also lead to loan default. So everything seems makes sense, right? Makes business sense. And you can see the right hand side is where you have the feature importance, and these are the top 20 features for regardless of whether positive or negative. It's just the most important drivers. You can see these two are similar, except that Shipley plot give you the whether it is a positive driver or negative driver. That is more insights, right? These, if you are not data scientist, just ignore this. But these are the ROC curve, precision recall, FI score versus threshold. If you want to adjust the threshold, you can do that. And you have false positive rate versus threshold. This is where you apply that to business. So you will have the partial dependence plot where you can see the probability of loan default versus a single variable with a single driver. I can say as you increase the interest rate, your probability of loan default actually increase. Also, as you increase your debt to income, so your probability of loan default also increase. Same thing for loan amount, right? You increase the loan amount, definitely your probability of default generally increase. So after we have trained our models, the next step is model prediction, where we load the model trained based on historical data, and we load the new record that will be either the batch processing or the real-time prediction into our system. So basically, this is where we're showing you we are loading one new model that is in the future. So we are trying to forecasting the results based on this particular record, right? This is assuming that you have a new applicant going on live, and you are trying to load the model, try to forecast. So you can see this is one record we are trying to predict, and we load the model, and load the record, and predict the probability of yes become this person applicant is default or not, right? This is a very good. This is like a no example, right? We predict this is should be the good loan. Or you can also use what if analysis. Say, what if I increase interest rate? Say what happens to this particular person if I increase the rate to very high interest rate, and also increase debt to income. So you can compare the results, right? You have this person. You can try to explain. This is also the Shapley plot. Try to explain the key driver for the result, right? You have the DTI is high, but also you have interest is low. So that means the original model predict the original record is being a good loan. But if you increase debt to income ratio and the interest rate, this person is gonna default, right? The probability of the being a loan default increase from less than 1% to 83%. So that is basically how model prediction works, right? Vice versa, you can probably select a bad example, right? You start with a bad loan. This person is a bad loan by start, a loan default by start, and we can adjust in the what if analysis. We can in the sensitivity we can try to adjust. Okay, what if we improve this person's debt to income ratio, make them lower, and what will happen, right? That will become yes. This will become from the bad loan to start. He or she will become a good loan. If you reduce turning one knob, just the debt to income to the lower end, you definitely can improve the results for this person, right? So enough for this. So giving you a single, we are trying to predict the single results, right? But what if we predict the entire population, and we can manage our the banking's portfolio, managing all this loan in group, right? So this is basically predict the loan default rate of financial business, have the business impact, where you have the new loan. You try to predict the loan is default or not, right? The probability of default, and you have the threshold and probability more than threshold. You can say we have more than the threshold will goes to decline the loan, and if the loan is actually bad, so which means you have a true positive case where you save a large amount of principals. If the loan is actually non-default, where you have a false positive case where you lose the opportunity cost for you lose the interest. And then if you have a probability less than the threshold, you are going to approve the loan, right? Think about how you frame this question. You can also do this vice versa, where you have you are doing a loan default, right? You can also doing the loan approval, right? You can basically you switch 0 and 1. Here we are trying to say, oh, if this is 0, you are gonna prove the loan, and you will have false negative, where you think the model says it's a good loan, but the loan actually default. In that case, that would be a lost of you are gonna lose all your principals. That is the worst case here. And if that is true, if you predict that is a good loan, and it is indeed a good loan, you have earned interest. So our optimized strategy for risk management will be maximize the recall and minimize the false negative, where you have this lost principal, right? You don't want that happen. So for the actual bad loans, we're going to measure how much of them are actually captured by the model. Also depending on your credit tolerance, how much loss you can tolerate, right? Your bad debt ratio. You can so if you don't want missing the opportunity cost by incorrectly predict the loan as bad loan, you can adjust your tolerance, you can adjust your threshold to be higher to have a fewer false positive in this case. But the side effect that you will have more false negative. So it will be a trade-off for the money manager or marketing the money manager bankers to decide, right? If we give the model. So if we adjust the threshold, we can use first 18 months to predict the future, to predict the loan default rate, and we're going to deploy the model in 6 months and check the business outcome, right? You can say the actual profit is where you have, it is what happened in June 15 to December 2015 there. You have actual earned loan interest minus your actual default loan amount, which is your bad debt. That equals to your actual profit, right, for the bank. You can see if you don't do anything, just approve anything, just do as it is, right? A traditional rule-based model, you're gonna have lots of negative profit or bad profit, right, for your bank. But if you are using our optimized loan results, right, where we are following this, we are using our model, we are training our model, and we deploy the model using this strategy, following this decision tree, we are gonna have the optimized profit where you have earned loan interest. We are gonna target. Remember, we're going to minimize this. We're going to minimize the lost principal, false negative case. We are also going to minimize, adjust the lost interest. So you will have some opportunity cost lost. But in overall, you are going to have your profit is going to jump from 0% to 27%. If you have tried to avoid this incorrect approved loan, right? You can say you definitely have lots of bad loans before and after. You are going to have very few bad loans, like 25 out versus 500. So in that case, you can greatly improve your rate of return of your portfolio as a bank or as a lending company, right? So that is basically the loan approval. So the second demo we're going to show you is we have a large scale. We just talk about the personal loan, right? Right now we are talking about corporate loan. So you have a corporate credit rating. We are going to predict whether the corporate bond is an investment grade or a speculative grade. We frame this again as a binary classification problems. But again, depending on your needs, you can also frame this as a multi-class classification versus regression problems. So some problem statement is that you have a U.S. corporate bond issued by year. You have a very large financial investment in corporate bond, right? Company are issuing bonds, so that is a huge investment in the world. So what you are trying to do is to predict whether this bond is an investment grade, which means they are lower risk, lower return, versus speculative grade, which means they are high risk, high return. This is important for investor because investors need to know this risk before they start to put the money manager put this into their portfolio, right? This will matter to your bond investment from a bank, from a financial institution, or from private equity fund. So we are trying. The data is we are gathering data from the public financial statement from the Fitch, Standard Poor, Fitch rating agency, and Moody rating agency, and also we do web scraping on the financial statement from the public U.S. public listed companies. There are 10K financial statement. You can gather them online. You can say you have income statement, balance sheet, and cash flow statement for these public traded companies, and you also have their credit rating by the top rating agencies throughout the year in the past 20 years. So you have 17,000 total observation, which means observation means the ratings, right? The rating and and their time. And you have 7,000 investment grade ratings, which means the rest of these are just speculative rating, junk bonds, high yield. And you have the past 20 years, and you have 1,500 companies. You can say this is a distribution of the ratings. You can say what is above BBB, including BBB, are we call investment grade rating. What is below BBB? So BBB, CCC, and CC are junk bonds, right? Or speculative grade bond, right? And these are the correlation metrics where you can see our target is whether that is an investment grade bond or not, right? If that is yes, that is an investment grade bond. If it is zero, no, that is a speculative bond rating. You can see the correlation between different features. You can definitely see some collinear features and what is the key driver for our target variables. And you can also see the debt ratio, right? If you have a higher debt ratio, you have a lower debt ratio, you are more likely to be investment grade rating. Or you can say net profit margin, right? If you have a higher net profit margin, you are more likely to be investment grade rating. So that make financially sense, right? That make common sense. So let's jump into the machine learning based on these data observations. We have trained data. We randomly, we split data by time, right? Before 2019, we have 14,000 records, 15,000 records, and we have what's after 2019 we use that as a test data. And again, same, we have the same proprietary AutoML library, AutoML machine learning algorithm to give you all the models with hyperparameter tuning and model fitting and cross validation, give you the best model results. So this is a model performance of our cross validation score versus test score, right? Where we have blind tests on this data. You notice that your accuracy is generally very high, but it's dropped a little bit in the test score. That makes totally sense because after 2019, you got COVID situation is where company, you make it concept drift or data drift because of the COVID situation, where company have a different metric for their bond rating, right? Their financial statement, their financial status conditions could definitely go worse for COVID, and you definitely have this shapely plot just like I showed you before for in the loan default, right? You have debt ratio. Higher debt ratio is the negative driver for investment grade. Higher debt ratio is definitely leads to more of a speculative grade, right? If you have higher cash flow, higher net profit, and higher profit margin, definitely leads to more of an investment grade. So that makes totally sense. And you can also see the feature importance based on similar to the Shapley plot, right? Which show you the key driver for the results. And again, this is the ROC curve, precision recall, false positive, and threshold. If you are not a data scientist, just ignore these. Model prediction is our where we have trained the model and we try to forecast into the future. What is giving the financial statement of the company, and we're gonna give their credit rating, right? So everybody knows Apple, so I'm using Apple as an example. You can say Apple is a great company that has 93% of the probability to become an investment grade, right? Of course, it is an investment grade. But what if we are doing some adjustment? What if the Apple is doing poor on the operational cash flow? What will happen is that it will become, or what if they have a return on capital is very low? Or what if it is heavily in debt? So something messed up, assume something messed up with a company like Apple. So you will become investment grade into junk bond or speculative grade. So you can definitely see the impact on these financial metrics to the overall credit rating for this company. So our last demo, our third demo, is where we are trying to have a situation probably in developing countries or for the people who don't have credit score. So we are trying to gather their public open transaction history in past 90 days, transaction history from the public bank data. This data is anonymous, so don't worry about any confidential thing. But you can say for any users, we are gathering their past 90 days transactions. Think about it when they are trying to apply for a loan, right? Apply for some credit. We are trying to gather their past transaction history, and we are trying to gather, generate using the advanced analytics, try to generate the insights of this person. So you have, we're showing this person, just different persons, right, in their past 90 days of transaction, and we are trying to calculate their number of transactions. You can see their total credit, which means their total income versus their total expense. So like this person example, although he may have lots of income, right? He report a high monthly income, but he also spend lots of money. So in net, he may have a net. His total balance is actually negative, right? You can see he definitely has a negative balance. You can see the moving daily balance for this person is actually negative. So this will help the bank or financial institution or the lenders to better evaluate the person's credit history without a credit score, right? If you don't know the credit score, this is a cold start. This will solve the bank's cold start problems. If I grab your bank bank's statement, and I will know your how much you spend, how much you save, how much your credit for your credit, right? For example, if you say your monthly net income is actually negative, so if you are trying to give a loan to this person, his net income to payment ratio is actually negative. So that, which means this person is probably a little bit risky than he appears to be. So this is this is basically a tool helps the bank to gather the insights, to generate the business intelligence for their customer. So yeah, you can also split this into different categories, right? You can say, oh, if I'm trying to see what is different buckets, right? The spending behavior of this person, what is spending behavior, what is the most category he spend, and also I want to divide this by expense. What is the expense? What is the income? What is the direct deposit for this person, right? So these are our this will conclude our demo. If you have any questions, just feel free to reaching rapidcanvas.ai. Thank you very much. Have a nice day. Bye bye.